This is assignment number 6. In this assignment, we're going to look at decoding the received information. And so you're going to create a file called hamming_dist.m in this assignment. I'm going to just briefly show you what you will do at the end. So start with is diary on, then hamming_dist, and then diary off. You're going to see first the received underscore data should be empty. This is what you use display function to have this checking for empty received underscore data array. 1 equals empty, and the answer is 1. Received data should be 6 elements in the array, and quant data is also 6, and it should be the value if the received data is greater than 0.5, you should see a 1 here. If it's less than, you should see a 0. So I can go through and check that, and I do indeed see that it is a 1 if it's above 0.5 and a 0 if it's not. Then I should see a 4 by 6 random array of numbers between 0 and 1. And again, I do. And then the code words should look like this. It should be a 4 by 6 array of 1s and 0s. And in the code words, if the value again is greater than 0.5, then I actually want to see a 0. And if it's less than 0.5, I want to see a 1. So this is just opposite of what you did above for the received data. So here I see that that is what's happening. I have 0.1527, which is less than 0.5, so I'll see a 1. This is greater than 0.5, I'll see a 0, 0, all the rest of these are zeros. Then I see 3 that are less than, so I'll see 1s, and then 2 that are greater, and then 1 less than, and I can go through and verify that the rest of those look correct. Then you're going to have this quant array, and quant array should again be a 4 by 6, and what it is going to be a replication of your quant data just repeated 4 times. So I check that it is the same. Next I'll see this code match. Code match compares quant array and code words. If they're the same value, it will have a 0. If they're opposite values, it will have a 1. So these will be the same here, 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 and then here I have a difference, so I should see a 1 in that place. And again, 0, zeros are the same, so I see a 0. And again, I have the same on the second row, but then I have a different one here. So that's code match. After code match, you're going to see hamming numbers. Hamming underscore nums is going to count up the number of 1s in each row. So the first number corresponds to the summation of the 1s in this one, which is 1. Then I have 4 for the second row. Then I have 3 for the next, and 5 for the last, and that is what I see here. Code match 2 is going to be the same thing as code match. It's going to compare the two using a different type of operator. So it should look the same as code underscore match, and it does. The last variable you'll see here is perfect underscore match, and perfect match will have a value of 1 if there's a match in any of the rows that are exactly the same. In this case, none of them are the same, and so I see all 0. Then I'm going to see this NANs and have an error in there, so you need to comment in your script file why you're getting this error. To begin this assignment, you're going to need to clear all of your windows, the command window, workspace, and command history. Then you're going to do a file new script, and this is going to be called hamming_dist.m. And you're going to first create an empty array called received data. To create an empty array, you just leave it empty. The next thing you're going to do is use a function called disp. All this does is again, you're using text, so we're going to use the single quote for text. So what this is going to do is just display on the screen what is in the single quotes. Here you'll see the first two commands in this assignment. The next step is to check if the array of the received data array is empty or not. I'm not exactly sure of the function, so I'm going to do a search by doing Shift F1 and typing in empty, and I see, okay, here's empty. Create an empty array, determine whether array is empty. This is the command that we want. So is empty, and then the array A returns a logical 1 if it's empty, a 0 meaning false if it's not. So we can just do that by typing is empty received underscore data, and we see that the answer is 1. The next thing we want to do is append the received data to itself, and then to add on to it 6 random numbers uniformly distributed between 0 and 1. There are a couple things for rand. We've already used rand n and rand perm. So this rand is actually the distribution between 0 and 1. So we'll use rand itself. So to append onto itself, it's just going to be received data, and then you do a comma, and then I want to do rand, and then I want 6 of them in an array, meaning that it will be 1 row and 6 elements. So if I do rand 6, it's going to give me a 6 by 6 matrix. So there's my received data with random numbers between 0 and 1, and it has 1 to 6 elements in it. Next, I want to use the greater than operator to quantize the bits into a 0, 1 if the values are less than or equal to 0.5, I want a 0 in this quant underscore data, and if it's greater than 0.5, I want a 1. I'll leave it up to you to create this quant underscore data. The next step is to create a rand array, and the rand array will be a 4 by 6 array of numbers evenly distributed between 0 and 1. Again, I'll leave this up to you to create the rand array in your script file. The next thing that you're going to need to do is this code underscore words. In code underscore words, you're going to again do a comparison. If this value now is less than 0.5, I want a 1. If it's greater than or equal to 0.5, I want a 0. So everywhere there's a 0.5 or less ones, and otherwise it needs to be a 0. So again, I'll leave this up to you to create this code underscore words. The next thing we need to do is create this quant underscore array. You're going to use a function here to do that, and the function is called repmat. And repmat looks like this, where you have repmat A and then M and N. It creates a large matrix that says B, which is a replication of A into the M by N size. So if A is equal to a 3-bit sequence, and we want A to be replicated 2 by 3, this is going to take the size of A, and it's a 1 row, so it's going to create it an M, which is going to be your rows first, so it's going to replicate it 2 rows, and it's going to repeat it 3 times across in the columns. So here I see the 110, then that's the second one is 110, and this is the third one, which is 110. So what you need to do is just create this quant array using quant data, And you want to replicate this quant data so that it is the same length, so you don't want it to go any more in the columns, but you do want to create it into 4 rows. And you're going to put that into the variable called quant array. So again, do that as an exercise on your own and create it so you get this quant underscore array. So now I'm going to use the Xor function. The Xor function returns a 1 when these two elements are different and a 0 when they're the same. So I'll get a 1 here and I'll get a 1 here, and what this is going to be used for is I want to compare the quant array and the code words to each other. Everywhere that they're different, I want to have it marked as being different. If they're the same, then I want a 0. So that is what the XOR can do. So I'm going to put that into a variable called code match. So I want code match everywhere that quant array and code words is different to be a value of 1, and everywhere that they're the same to be a 0. Use that XOR function, and again, I'll leave it up to you to create that in your script file. So what I am trying to achieve here is the comparison between the data I'm receiving, which is in this quant array. Each row of these is what the data was that I received, and I want to compare it to my code words to see which one does it closely match. So either it's going to be a perfect match, but if we have errors, then I might be off by 1 bit, or I might be off by 2 bits. So I want to find the one that closely matches, as close as possible, one of the code words. So one way to do that is to look at the differences between them, and that's what I've done here in code match, and then I can sum all of the numbers here to see which one has the lowest amount of numbers. What I would need to do is to sum each of these rows. So there is a sum function. What sum does is that it will, if it's an array, it will sum the columns in the array. So if I sum the code match, that is going to sum everything in this column. Everything in this column will be this value, everything in this column will be this value, but that's actually not what I want to do. I want to sum everything in an entire row. So to do that, I can transpose the code underscore match by using the little single quote, and that will alter each of the rows into a column form. And as I see here, I'll have 4. The first value will be the first row, which will be 3. The second one will be 4. The third one will have only 1. And the fourth one will have only 3. So I see here that the one that closely matches is going to be the minimum out of all these numbers, and in this case it will be the third row. So the summation of each of these I want to place into a variable called Hamming underscore nums. And so the Hamming underscore nums will be the value from that sum code match. Next I want to use the equals operator and the tilde operator to create an array called code underscore match 2. And code under match 2 will also use the same variables as code match, the quant array and the code words. Again, it's to create, if they're the same, I want a 0. If they're different, then I want a 1. So use the equal operator and the tilde, where the tilde, if the value is 1, this is called the not operator. So if I get a 1, I want not 1, so I'll be 0. And if I have a 0 and I want not 0, I get the 1. So I'm going to use that as an exercise to compare just using the equals to get the same code match 2 to equal the same as code underscore match. So these two should be the same, just using different operators. The next thing I want to do is use the any function to determine if there is a perfect match between the quant underscore data and the code words. So the any function tests whether any of the elements are a non-zero, and if so, it will return a logical 1, meaning true. So when we did the comparison, ones meant that the 1 and 0 of the quant data and the code words was different. So if we have all zeros across, it means that it actually is the same and therefore would be a perfect match. So the any function, just like the sum function, looks at a column. So I could use either code match or code match 2 would be the same. So if I do this, it's going to return how many columns I have, which is 6. So I want to make sure that I transpose this to be able to be comparing a row. And I see here that I do not have, the first row has a 1 in it at least, so that's going to be a 1. If it's all zeros is when I'll return a 0. So we want to use perfect match is our variable, and I want to know in our perfect match if we have any that are a perfect match, meaning that 1 should show up here if I have a perfect match. So I want to use the not operator also to be able to convert this from 1s to 0s. So use the not operator. Where a 1 represents a perfect match, the 0 will represent that it did not match. So go ahead and do this in your script. Use the any function along with the not operator to be able to determine a 1 if you do have a perfect match. So suppose there's a glitch out there in space as you're transmitting the data, and you get not just a 0 or 1, but you get a NaN, a not a number. So NaN does show up in here as NaN. So we want to understand, do you get an error like this? Is it going to crash your program? Does the NaN act like a certain bit value? Does it make a difference whether we use XOR or equals with it? So I want you to comment in your file about this NaN. So one way to kind of play around with the NaN to see what it does, you can set one of your values in the quant data to equal NaN and see what you get back. Here it's showing that NaN cannot be converted to a logical. So my quant data does not change. If I use it in an XOR, I see that XOR NaN cannot be converted to a logical number, and if I use it with a 1, again it says comment that it cannot be converted to a logical. So see what happens when you're equal. It does actually operate when you have an equals. So make comments in your file about the NaN value. So this is the conclusion of this assignment. So save your hamming_dis.m file and clear your windows and do diary on. Run the hamming_dist and do diary off. Go up and check to make sure that everything is correct. You have received data is empty. You display this. You have the answers 1. You have an array of 6 random numbers between 0 and 1. This value should be a 0 if it's less than 0.5, and if it's 0.5 or greater, it should be a 1. Your rand array is a 4 by 6 random numbers again of between 0 and 1. Your code words is a 1 if it's less than or equal to 0.5, and a 0 if it's greater than 0.5. So I look through here and that is correct. My quant array should be just a replication of the quant data in 4 rows so that I can compare the code words and the quant data together. And so I get my code match. If these bits are the same, I should have a 0. If they're different, I should have a 1. And then I should get, in the Hamming underscore nums, I should get a summation of everything that is 1 in each row. So I get 1 here, 4, 4, 4. And my Hamming underscore nums, I see that I have that is correct. I then have code underscore match 2, which should equal code match. I then see that I don't have a perfect match. I compare this to the Hamming nums, and I do have all zeros, meaning that there's not a 1, that there's not an exact match. And then I have the comment in my file about the NAN. That's the conclusion of this assignment.